Welcome back to Cosmos in a Pod Space and Astronomy Series, Episode 3. Today, we're diving deep into one of the most, I don't even know, mysterious, mind-bending phenomena in the universe. Black holes.
Yeah, they're not just these, cosmic vacuum cleaners that kind of suck everything up, right? They really make us rethink like how we understand space and time.
Okay, but before we get, sucked in to the mysteries of black holes, maybe we should start with something a little more familiar. Stars. I mean, you see them every night.
Exactly, and it turns out the life cycle of certain stars is really connected to the birth of black holes.
So walk us through it. How does a star, this bright shining thing, become a black hole, this region of space-time where not even light can escape?
Yeah, so it all begins with these massive stars, much bigger than our sun, and these stars live fast and die young, astronomically speaking, of course. They burn through their fuel super fast and eventually, well, they run out.
And then does the star just, fizzle out?
Well, not exactly. When the massive star runs out of fuel, gravity just takes over. The star's core collapses in on itself. And it leads to this, mega explosion, a supernova. It's this huge cosmic fireworks show, this burst of light and energy that can be brighter than a whole galaxy for a short time.
Wow, that's quite an exit. But what happens after, the fireworks are over?
That's where things get really interesting. Sometimes the core that's left over from the supernova, it's so massive, so dense that its own gravity just becomes inescapable. It keeps collapsing, squeezing itself down into this tiny, tiny point called a singularity.
A singularity, so all that matter in the star gets squished down into, a point with no volume. That's hard to picture.
It is, and that's where our current understanding of physics kind of breaks down. This singularity gets covered by something called the event horizon. That's the point of no return. Anything that crosses it, even light, gets trapped by the black hole's gravity.
So we've got this, super dense point, the singularity, and it's surrounded by the event horizon, this boundary that you can't come back from. But how do we even know black holes exist if we can't see them, since they're black?
That's a really good question. We can't directly see black holes, but we can see how they affect the stuff around them. Like if you were trying to find a ghost, you can't see the ghost itself, but maybe you'd see things move or lights flicker because of it.
So what are the signs? What tells us there's a black hole hanging around?
One way is by looking for these pairs of a black hole and a star orbiting each other. The black hole's gravity pulls matter from the star. It creates this swirling disk of superhot gas, and that's called an accretion disk.
This is like the black hole is having a snack, taking a bite out of its neighbor.
Exactly. And as this matter spirals into the black hole, it heats up, emits all this intense radiation, X-rays. And we can detect those X-rays with our telescopes. That's our clue that there's a black hole there.
It's like a cosmic fingerprint, huh? So let's talk about a really famous black hole. Sagittarius A, the one at the center of our Milky Way galaxy. What makes it so special?
Well, for one, it's massive, 4 million times the mass of our sun. It's like this giant anchor holding our galaxy together.
4 million suns, wow. How did we figure out it was even there, let alone measure how massive it is?
By watching the stars that orbit it, astronomers have been tracking how stars move near the center of our galaxy, and they noticed these stars were zipping around some invisible object at super high speeds.
So by looking at the way these stars move, we know there's this massive thing there that we can't see.
Exactly. And you remember that incredible image of a black hole shadow from the Event Horizon Telescope a while back? That was Sagittarius A. It was the first time we actually got to see the region around a black hole's event horizon. More proof that these incredible things exist.
Okay, so we've been talking supermassive black holes, but are there other kinds?
Yep. Black holes actually come in different sizes. We have stellar black holes, which are formed when a single massive star collapses. They're typically just a few times the mass of our sun.
So like the baby black holes compared to the supermassive ones.
You could say that. And then there are these more hypothetical objects called primordial black holes.
Primordial black holes, what are those?
These are thought to have formed way back in the early universe, right after the Big Bang. They could be tiny or they could be massive, but we haven't actually confirmed they exist yet.
So there's still kind of mystery, but the idea that they could be out there is pretty wild.
Definitely. But what really sets black holes apart, besides just being really dense, is that they can warp both time and space. It's like they have a whole different set of rules.
Right. I've heard about that. Doesn't that have something to do with Einstein's theory of general relativity?
Yes. General relativity tells us that massive objects like black holes actually distort the fabric of space-time.
So black holes aren't just, pulling things with gravity. They're actually changing the way space and time work around them.
That's it. And one of the most amazing results of this warping is something called time dilation. This means time actually slows down near a black hole compared to someone observing from farther away.
Wait, hold on. So if I was hanging out near a black hole, time would move slower for me than for someone back on Earth.
That's exactly right. It's like black holes have their own time zones where the clocks run differently.
My mind is blown. So let's say, hypothetically, I take a trip to a black hole and then come back to Earth. Would I have aged less than everyone else?
In theory, yes. But actually getting close enough to a black hole to really see this time difference is a whole other challenge, and surviving the trip is another thing altogether.
Let's just pretend we could survive a trip to a black hole for a second. What would happen if we crossed the event horizon, that point of no return? What's on the other side?
That's where things get really mysterious and a bit scary. The main idea is that if you cross the event horizon, you'd experience something called spaghettification.
Spaghettification. Doesn't sound too good. What exactly is that?
Basically, as you get closer to the black hole, the gravity pulling on your feet would be much stronger than on your head. So you get stretched like spaghetti until you're ripped apart, down to the atoms.
Okay, yeah, I'll pass on that trip. What about the singularity? What happens at that infinitely dense point in the middle?
That's still one of the biggest questions in physics. Our understanding just breaks down there. Some think it could be a gateway to another universe, or maybe even like a time travel portal. But honestly, it's mostly uncharted territory for now.
So maybe black holes aren't the best vacation spots.
Probably not. But even though we can't physically travel to one, we can still study them. And with every new thing we learn, we understand more about these amazing objects and their role in how the universe works.
So black holes aren't just these random weird things in space. They're actually a part of the bigger picture.
Exactly. And they're not just about gravity and relativity either. They also connect to the world of quantum mechanics in some surprising ways. But that's a topic for another time.
All right, sounds good. I'm definitely ready to learn more. Black holes are clearly much more than just empty space. They are truly mind-boggling objects. And to our listeners, we'll be right back after a short break. Don't go away.
See you soon.
Welcome back to our deep dive into black holes. Before the break, we were talking about how they warp time and space and how they make us rethink gravity and relativity.
Right, but what's really cool is that black holes also push the boundaries of another big theory in physics.
Right.
Quantum mechanics.
Quantum mechanics. I thought that was about the really tiny stuff, atoms and particles. How does that connect to these giant black holes?
It turns out black holes aren't totally black. They actually give off a faint kind of radiation called Hawking radiation, and this comes from quantum effects happening right near the event horizon.
Hold on, black holes give off radiation. I thought nothing, not even light, could escape them.
That's true for things that cross the event horizon, that point of no return. But down at the quantum level, things get a little, well, weird. In quantum mechanics, empty space isn't actually empty. It's full of these things called virtual particles, popping in and out of existence all the time.
Virtual particles, what are those?
Think of them like pairs of particles and antiparticles. They come from the vacuum of space, exist for a super short time, then they destroy each other, and their energy goes back to the void. It's like this constant creation and destruction happening all the time.
So empty space is actually buzzing with this quantum stuff we can't normally see.
Yeah, that's the idea. Now imagine this happening near a black hole's event horizon. Sometimes one of those virtual particles falls into the black hole while the other one escapes. And that escaping particle becomes a real particle, carrying away some of the black hole's energy.
So it's like the black hole's leaking energy through these particles. But wouldn't it have to travel faster than light to escape the black hole's gravity?
This is where quantum mechanics gets really interesting. Virtual particles don't follow the same rules as normal objects. They can do things that normal physics says are impossible, like being in multiple places at once or tunneling through barriers.
So they're like quantum escape artists, huh? Finding loopholes in reality.
That's a good way to put it. And over really, really long periods of time, this Hawking radiation makes the black hole lose mass, and eventually it could even completely disappear.
Black holes can disappear. I thought they were, like, forever.
That's what we thought too. But this theory challenges that idea, and it brings up some big questions about information.
Information? What do you mean?
Well, quantum mechanics says information can't be destroyed. But if a black hole disappears, what happens to all the information about everything that fell into it? Did it just vanish?
It's like when you burn a book. The book is gone, But the words, the stories, that information isn't really gone. It's just changed into other forms of energy.
Exactly. So the question is, does something like that happen with black holes? Does the information about everything that fell in get encoded in the Hawking radiation somehow? Or is it lost forever? This is called the information paradox, and it's a huge mystery in physics.
That's a pretty big paradox, all right. And it seems like it goes to the core of how we understand the universe. If information can be lost, that changes a lot of what we thought we knew.
It does. And it shows us that we need a better theory, one that combines the big world of gravity described by general relativity with the small world of quantum mechanics. We need a theory of quantum gravity.
Quantum gravity, yeah, we keep coming back to this. Like every time we try to understand these big cosmic mysteries, we need this theory that can explain it all.
Exactly. And black holes, with their crazy gravity and their connection to quantum stuff, are the perfect place to test ideas about quantum gravity. They're making us rethink the very basics of the universe: space, time, information, all of it.
It sounds like black holes aren't just these objects in space. They're like keys to unlocking deeper truths about how reality works.
That's a great way to think about it. They're pushing the limits of our knowledge and forcing us to ask really big questions. And who knows what answers we might find as we continue to explore them.
Well, I'm ready to dive even deeper. Black holes have certainly shattered any preconceived notions I had. Now I want to move on to something a bit lighter. We've talked a lot about the darkness of black holes. How about we explore the possibility of light and life beyond our planet?
That's a perfect transition, leaving the intense gravity and mind-bending physics of black holes behind and venturing into the search for other worlds and maybe even other life forms.
The age-old question, are we alone in the universe? It's a question that has fascinated humanity for centuries. And now, in recent decades, we've made remarkable progress in our ability to search for answers.
With powerful telescopes and ingenious techniques, we're discovering new planets orbiting distant stars at an incredible rate. Thousands of exoplanets, planets outside of our solar system, have been confirmed, and there are undoubtedly many more waiting to be found.
Thousands. Wow, that's a lot of planets. What are these exoplanets like? Are they similar to the planets in our solar system?
Some are, but many are quite different. We have found gas giants larger than Jupiter, rocky worlds similar in size to Earth, and everything in between. Some are scorching hot or getting close to their stars, while others are icy and distant, locked in a perpetual winter.
It sounds like there's a whole spectrum of planetary possibilities out there.
That's right. And as we learn more about these exoplanets, we're starting to ask even bolder questions. Could some of these worlds harbor life?
That's the big question, isn't it? Are we alone in the universe, or is there life teeming out there on other planets?
It's a tantalizing thought. Imagine oceans on distant planets, filled with alien creatures unlike anything we've ever seen. Or perhaps even intelligent civilizations gazing up at their own night skies and wondering if they're alone.
It's mind-boggling to think about the possibilities.
It is. And the search for life beyond Earth is one of the most exciting and rapidly developing fields in science.
So how do scientists actually search for life on these distant planets? I mean, we can't exactly send probes out there to collect samples, can we?
Not yet, at least. But scientists are developing incredibly sophisticated instruments and techniques to study exoplanets from afar. One approach is to analyze the light that passes through an exoplanet's atmosphere.
So it's like looking at a distant streetlight through fog. The fog changes the way the light looks, right?
Exactly. By carefully studying the light from a distant star that has passed through an exoplanet's atmosphere, scientists can detect the presence of certain gases, such as oxygen, methane, or water vapor. These gases could be signs of biological activity, or what we call biosignatures.
So if we detect oxygen in an exoplanet's atmosphere, it could be a sign that there are plants or other organisms producing oxygen through photosynthesis, just like on Earth.
That's the idea. And as our technology advances, we're getting closer to being able to directly image these distant worlds. Imagine being able to see an exoplanet with your own eyes, to see its continents, its oceans, perhaps even signs of vegetation.
It would be like looking through a window into another world.
It would be an extraordinary achievement. And who knows, maybe one day we'll be able to send robotic probes to these exoplanets to explore them up close.
I can't wait to see what the future holds for exoplanet research.
Yeah.
It feels like we're on the verge of some truly groundbreaking discoveries.
I agree. The search for life beyond Earth is a grand scientific adventure, and it has the potential to change our understanding of our place in the universe.
If we were to find evidence of even microbial life on another planet, It would be a monumental discovery, wouldn't it?
Absolutely. It would demonstrate that life is not unique to Earth, that the spark of life can ignite in other corners of the cosmos.
And what if we found evidence of intelligent life? That would be truly transformative, wouldn't it?
It would be a paradigm shift. It would force us to reconsider our place in the universe, to acknowledge that we're not the only intelligent beings out there.
It's both exciting and humbling to think about.
It is. And it reminds us that the universe is full of mysteries and wonders waiting to be uncovered.
Well, we've covered a lot of ground today, from the depths of black holes to the tantalizing possibilities of life beyond Earth. It's been a journey of cosmic proportions.
It has. And it's a journey that's only just begun. As our understanding of the universe deepens, we're sure to encounter even more mind-boggling phenomena and profound questions.
And that's what makes exploring the cosmos so captivating, isn't it? There's always something new to discover, always another mystery to unravel.
Exactly. And it's a reminder that we should never stop asking questions, never stop pushing the boundaries of our knowledge.
Well said. So until next time, keep looking up, keep wondering, and keep exploring the vast and mysterious universe.
And if you've enjoyed this deep dive into the cosmos, be sure to follow and subscribe to Cosmos in a Pod. We'll be back soon with another adventure into the wonders of space and time.
Okay, so black holes really can just disappear over time. That's wild.
It is, and it raises some really big questions about, what happens to the information that falls into a black hole. That's actually a big mystery in physics.
Yeah, we touched on that a little bit before the break. It's like if you throw a book into a fire, the book burns up, but the information in the book, the words and stories, they don't just disappear, do they?
Exactly. So where does that information go when it falls into a black hole? Does it get destroyed? Or is it somehow preserved? That's what physicists are trying to figure out.
It seems like black holes really push the limits of what we know about the universe.
They do. And that's why they're so fascinating to study. They force us to confront some of the biggest questions in physics. Like, how do we combine our understanding of gravity with our understanding of quantum mechanics?
That's where the idea of quantum gravity comes in, right?
Right. We need a theory that can explain both the really big stuff, like black holes and galaxies, and the really small stuff, like atoms and particles.
It's like trying to fit two giant puzzle pieces together.
Exactly. And black holes might be the key to figuring out how those pieces fit.
Well, I have to say, my mind is officially blown. I never thought I'd be so fascinated by these giant cosmic enigmas.
That's the beauty of science, right? The more you learn, the more you realize how much there is still to discover.
Speaking of discovering, you know what I'm ready for? A change of pace. We've been exploring the darkness of black holes. Now I'm thinking about the possibility of light and life beyond our own planet.
Yes. The search for exoplanets and the tantalizing question of whether we're alone in the universe.
Exactly. It's like, after delving into the depths of black holes, I'm craving a bit of cosmic optimism.
I understand. The search for life beyond Earth is certainly a hopeful endeavor, and it's one that's been gaining incredible momentum in recent years.
I've heard about all these discoveries of planets orbiting other stars. What are they called again?
Exoplanets. They're planets that exist outside of our own solar system, and thanks to advances in technology, we're finding them at an astonishing rate.
Thousands, right?
Thousands indeed. And they come in all sorts of varieties. We found gas giants bigger than Jupiter, rocky planets about the size of Earth, and everything in between.
So it's like a whole cosmic zoo of planets out there.
You could say that. And as we learn more about these exoplanets, we're starting to ask even bolder questions. Could some of these planets be habitable? Could they harbor life?
That's the ultimate question, isn't it? Are we alone?
It is. And the search for life beyond Earth is one of the most exciting and rapidly developing fields in science.
So how do scientists actually search for life on these distant planets? We can't exactly send a rover over there, can we?
Not yet, anyway. But scientists have developed incredibly sophisticated ways to study exoplanets from afar. One technique is to analyze the light that passes through a planet's atmosphere.
So it's kind of like when you look at a street light through fog, right? The fog changes the color of the light.
Exactly. By carefully studying the light from a distant star that has passed through an exoplanet's atmosphere, scientists can figure out what gases are present.
And if it finds certain gases, like oxygen, that could be a sign of life, right?
Right. Oxygen, methane, water vapor, these are all potential biosignatures, indicators that there might be some kind of biological activity going on.
That's incredible. So we can actually learn about the composition of these distant planets' atmospheres from billions of miles away.
It's pretty amazing, isn't it? And as our technology continues to improve, we're getting closer and closer to being able to actually see these planets directly.
Imagine that. Seeing another world with our own eyes. A world that might be teeming with life.
It would be a truly revolutionary moment.
It would change everything, wouldn't it?
Yeah.
Our whole understanding of our place in the universe.
It would be a profound shift in perspective. To know that we're not alone, that life exists elsewhere in the cosmos, would be a discovery that would reverberate through all of humanity.
Well, I, for one, am incredibly excited to see what the future holds for exoplanet research. Who knows what incredible discoveries await us out there?
Indeed. And it's a reminder that the universe is full of wonder and possibility. From the mind-bending depths of black holes to the tantalizing promise of life beyond Earth, there's always something new to explore, always something new to learn.
Well said. And on that note, I think it's time for us to wrap up this cosmic journey. It's been a truly awe-inspiring exploration of the universe, from the darkest corners to the brightest hopes.
It has. And I want to thank everyone for joining us on this deep dive into the cosmos.
If you've enjoyed this episode, be sure to subscribe to Cosmos in a Pod so you don't miss our next adventure into the wonders of space and time. And remember, keep looking up, keep wondering, and never stop exploring the vast and mysterious universe.
Until next time.